is x plus 60. They're asking for the value of y, and the answer is x plus 60. Scott? Anyone? Carson?
Is it because x and y are corresponding, like, balance on the inside and then balance on the...
Not necessarily. They're not corresponding. Val?
Because, so the triangle, every corner angle is 60, so then x would equal 60 since they're vertical angles.
Someone else said that in my class earlier. We do not know that this is equiangular. You cannot make that assumption. But that's a good try. Bryson?
Because you need to know all the degrees in the triangle to find y.
Okay. What
Or
are...
at least the bottom left, or the bottom one.
Okay, so
X is vertical angles.
we're missing this one, right?
Yeah.
Okay.
So x is vertical angles.
Oh, so this one has to be x as well.
Yeah.
Very good, because they're vertical. Excellent.
So you need to add 60 and whatever x is to find 180.
Okay, so it'd be 180 minus 60 minus x. That'll give me this angle, correct?
Yeah.
Okay, how does that relate to y?
Because y is corresponding, or it's they would equal to 180.
You're on the right track, but this is not how we do it. I love that you said that this was vertical, though. Yeah, Kristen?
X plus 60 gets 1.
Why?
Y is... I forgot the triangle.
What is y? Is it not an exterior angle of a triangle? The exterior angle of a triangle, you ignore the angle that's next to it and you add the other two. So wouldn't y just be equal to x plus 60? Do you guys remember that? Guys, this is straight from the SAT, okay? This stuff matters. If you got it, give yourself a pat on the back. Not many people did. If you didn't, ask me questions. What don't we understand? Or did light bulbs go off? No? Another, yeah, right. Grayson?
Y could have been
B, 2x? Because we don't know what x is. Where are you getting 2x from?
Oh, I just thought since the triangle is, and it's one that says 60, all sides are 60.
No. Not all angles are 60 degrees. If two of the angles were 60, then we know the third one's 60 because we can subtract it from 180. Another way to do it, guys, is along the lines of what Bryson was saying. So do you guys agree that this missing angle that we don't know, I shouldn't put an X there. Let me just scribble it out. This missing angle that we don't know is 180 minus 60 minus X, correct? Now, if I took that away from 180, if I did 180 minus this value, wouldn't that be what y is? Because isn't y going to be this value subtracted from 180 because they're supplementary? Don't the 180s cancel? And you have y equals positive 60 plus x. Regardless of how you do this problem, though, okay, you should end up with 60 plus x. You add those two interior angles to give you the exterior one. Here we go. So today we've learned about the shape parallelogram, right? Now we're going to be given a shape, and we're not going to be given much information about the shape, but we're going to be asked, are we given enough to prove that that shape is a parallelogram? Okay, so let's first identify all the things that we know about parallelograms. What are some of the stuff that we know about parallelograms, the shape? Yes? Very good. Opposite sides are congruent. What else do we know about parallelograms? John? Yeah, buddy. Opposite angles are congruent. Cody?
There's two sets of parallel lines.
Very good. Two sets or two pairs of parallel sides. What else do we know about parallelograms? Yeah, Christian.
That the two angles next to each other are equal length.
Yeah, buddy. The two angles, we're going to say adjacent, okay, which means next to each other. Or we can say consecutive. Put a slash there. You can use either of those words. Must add to 180 degrees. Is there a word that we can replace that with?
Supplementary.
Supplementary. Is there anything else that we know about parallelograms? We're missing only one more thing. Yep. Oh, the exterior angles equal up to 360. Yeah, that's true for all shapes, all polygons. Yeah. Yeah, Carson?
Is it the diagonal?
What about the diagonals?
Bisect.
Mm-hmm. The diagonals bisect each other. Very good. So guys, anytime in a problem, if we're told something's a parallelogram, all of these things become applicable. And I know we know this because of the scores on the quiz, okay? So we're very proficient at being able to say, okay, this is a parallelogram. This is all the information I know about this parallelogram. What we're doing today is it's going to be like a little bit of like a mind trick for you, because now we're going to see a figure. It's going to have information on it, and it's going to be like, do you have enough to prove that this is a parallelogram? And the 4 theorems that we learned today are all converses, because we're doing the opposite of what we were doing before, okay? So the first one involves the opposite sides converse. Parallelogram, opposite sides converse, which says if both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral must be a parallelogram, okay? So the only piece of information it's giving you is 2 sets of congruence marks opposite each other in a quadrilateral. We can make the assumption that it's a parallelogram. Now, this is the converse because the hypothesis and the conclusion were reversed. Do you guys see that? We're saying opposite sides are congruent first now, and then our conclusion is that it's a parallelogram, okay? Make sure you notice that. If we're not given that it's a parallelogram, you're always going to use the converse. The next theorem that we have is opposite angles converse for parallelograms. It says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Again, 2 pairs of congruence marks on the angles showing that we have opposite angles are congruent. B and D are congruent, and A and C are congruent. Any questions on the first 2 theorems so far? Okay, our third theorem says opposite sides parallel and congruent theorem. Please underline and. They have to be both parallel and congruent, but only one set of them has to be parallel and congruent, okay? Only one set has to be both. It says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. Now, a common mistake that I see a lot of times is students will think that a figure that looks like this, where it has parallel sides and separate congruent sides, that this has to be a parallelogram. Does this have to be a parallelogram? No. The answer is no, because it says a set, right? So that means the same set must be both parallel and congruent. Do you see how both sets of sides are being used as parallel and congruence? This is a big no-no, okay? This is what you're looking for. If the same set of sides is both parallel and congruence. One way a student thought about it last year that really helped them was they said, okay, the marks need to be on the same side, right? If it's going to use this theorem, the parallel mark and the congruence marks must be on the same sides. You shouldn't touch the CD and the AB, okay? Those should be left up for question. All right? Any questions on this theorem? All right, and our last theorem involves what Carson said, the diagonals, okay? The diagonals converse. So if you know that the diagonals are bisecting each other, they're cutting each other in half, your conclusion is enough to say that it's a parallelogram, okay? Now, when we are proving something's a parallelogram, there ends up being 5 ways. The 4 theorems we just learned about, and put a star next to number 1. You are also able to show that both pairs, opposite sides, are parallel. Okay? Now, does anyone know what theorem that is? How do we know that both pairs of sides are parallel to each other in a parallelogram? Does anyone remember? Yeah?
Parallel to converse.
No. It's not going to be like any theorem that we learned today, yeah? It's not one that we learned today, guys. So how do you define a parallelogram? Do you guys remember the definition of parallelogram? The definition of a parallelogram? What word is in the word parallelogram? Parallel, right? So a parallelogram, by definition, is 2 pairs of parallel sides, right? So that's what this one is. It's the definition of parallelogram. Okay? So by definition, a parallelogram is where you have a quadrilateral that has 2 sets of parallel sides which are the opposite sides, okay? Number 2, you can show that both pairs of opposite sides are congruent. That's the opposite sides opposite sides converse. Show one pair of sides are parallel and congruent. That's the parallel and congruence theorem. And then 4th one, show both pairs of opposite angles are congruent. Opposite angles converse. And show the diagonals bisect each other, okay? There's 5 ways we can prove that a figure is a parallelogram, okay? All right. The next slide is very, very useful because it relates each of these theorems plus the definition of a parallelogram to like an actual picture. So if we're going to show any of these figures on the right are parallelograms, we can, and it's based on the theorem on the left, okay? So any of these on the right could be given to us, and we would be able to prove that they are parallelograms. Do you guys want to try some examples? All right, let's do it. So in example 1, it says we're going to be given some information about this figure, like, for example, congruence marks or something. And we're going to be asked, okay, what theorem proves that that figure is now a parallelogram based on what's given? So let's take a look at number 1, okay? In number 1, it says BE is equal to ED. So this piece is equal to this piece. And it also says that CE is equal to EA. So those are the same distance. Given this information, what theorem would prove that this figure is now a parallelogram? Kristen? Very good. This would be the parallelogram. Diagonals. Converse. Okay? Now, the reason it's the converse is because we were proving what? What did we just prove? Not congruence, right? Congruence was given to us. What did we just prove? That it's a parallelogram, okay? Whenever you're proving it's a parallelogram, it's going to be the converse. Whenever you're told, hey, this is a parallelogram, guys, what can you conclude from it? That's the regular theorem, which would be the diagonals theorem of a parallelogram, okay? The second one, it says the angle BAD is equal to the angle DCB. So let's go ahead and figure which ones those are. BAD is this guy, right? And DCB is this guy, so those are congruent. And then it also says angle ADC is equal to CBA. So those are our marks. What do you guys think? Yeah, Nick?
Parallelogram and converse.
Yeah, parallelogram. Who said opposite? Very good, Carson. It needs to be opposite angles converse. Does anyone know why it's the converse again? We're proving that it's a parallelogram. It should be a converse theorem for almost all of these, okay? All right, number 3. It says BC is parallel to AD and AB is parallel to DC. Let's go ahead and put those as markings on our figure. BC being parallel to AD and BAB being parallel to DC. Now you can go up one more slide and try to figure out, okay, which one can we use to prove that it's a parallelogram now? Yeah?
Definition.
Very good, Kristen. This one would be the definition of a parallelogram. Because what is the definition of a parallelogram? Both sides are equal?
I mean, both sides are congruent.
No, not congruent. Both sides are parallel. Okay, we need 2 pairs of parallel sides. Definition of, and then we'll put parallelogram. Okay, in the 4th one, we have BC is equal to AD and AB is equal to DC. All right, let's put that on our figure. BC is congruent to AD, and then AB is congruent to DC. So using those green marks, what theorem can I use to prove that it's a parallelogram? Anna?
Parallelogram, opposite side property.
Very good. Parallelogram. Opposite sides. Converse. Okay? Because if I know opposite sides are congruent, then I know that this has to be a parallelogram. Converse because we were proving what? What are we proving here? That it's a parallelogram. Okay? All right, now the last one. It tells us that BC is not only parallel to AD, but it's also congruent to AD. So we're going to have a parallel symbol here, a congruent symbol here, parallel symbol here, and a congruent symbol here in yellow or some other color. If you were to ignore all the other marks, what could we use here to help us prove this, that this is a parallelogram? Nick?
Opposite sides parallel and congruent theorem.
Very good. Opposite sides. Parallel, I'm going to abbreviate parallel with the symbol, and congruence theorem. And this is parallelogram in the beginning. So guys, between the regular theorems and these, we've got about 8 of them, plus the definition of a parallelogram, so about 9 in total, okay? It is quite a bit to keep up with, okay? You will get better the more you're applying them, but you should start to remember, okay, I know that opposite sides are equal. A lot of the theorems, guys, they are exactly how they sound. So if it says opposite sides congruence theorem, right, you know, oh, opposite sides of a parallelogram must be congruent, right? So it's just a matter of knowing the concepts versus knowing what the actual theorems are, okay? So know how you learn the best. If you're a person that just likes to memorize, then make a Quizlet for yourself. If you're one of those people that likes to apply, just do a bunch of problems and then it's going to be second nature to where you're applying these theorems for yourself, okay? All right, let's try another one. So for what values of x and y is this quadrilateral a parallelogram? So we've got this figure. We want it to be a parallelogram, but we don't know that it is right now. We have to create values for x and y that would make it a parallelogram. What needs to be true about x and y? Do we have any ideas? Juan? Sure. Yeah, Nick? PQ must be equal to SR. Why?
Because they're opposite sides.
Very good. These two are opposite sides. And in order for this to be a parallelogram, do you guys agree opposite sides would be equal to each other? Okay. So now, what do I set up to solve for variable?
X plus 9 equals to x minus 1.
X plus 9 equals 2x minus 1. Very good. All right, so if I started there, how do I solve this? Reagan, go ahead.
You said x plus, you do plus 1 to the 9.
Okay.
And then subtract x. And then x equals 10.
And then x over here equals, and then we get 10. Remember, these canceled, so x equals 10. She did both steps in one. Did I lose anyone there? Are we good on that? We've done like a million of these problems if you had me last year, okay? We're Gucci? Okay, so if x is 10, how do I find y? Elias?
Plug it into x plus 7.
Very good. Take that 10 and plug it in over here. So this side is going to be what? What's RQ going to be? RQ is going to be 17. And that should be the same as what? PS, which is just y. So what is y equal to? 17 as well. Okay? Does anyone know the theorem we just used here? Remember, we didn't know at the beginning, we did not know this was a parallelogram. Yeah, Kristen? Very good. This is opposite sides converse. Okay? Opposite sides converse. Any questions on this one? Look it over again. Okay, now, could I have started by setting y equal to x plus 7? Could I have started with this? No, why not? Does anyone know why not? Juliet? Excellent. There's two variables in how many equations? One, right? You have to solve for one of your variables. So then once you get to this step, you should know, okay, I'm going to save that for last because I don't know what x is, right? And then you'd be like, okay, x plus 9 is equal to 2x plus 1. I can solve for x there and use that value then to solve for y, okay? All right, next question. We're almost done, guys, okay? For what values of x and y is the quadrilateral ABCD a parallelogram? What do I do? Sophia?
3x minus 32 equals 2x.
Yeah. Why?
Because for it to be parallelogram, it should be congruent angles.
Very good. Opposite angle should be congruent. Let's just write that in there. The measure of angle A is what Sophia's saying, should be equal to the measure of angle C because they are opposite each other in what we're trying to say is a parallelogram, right? All right, Sophia, how would you go about solving this?
Subtract 3x from both sides.
Okay.
And you get negative 32 equals the negative 1x. And x is equal to 32.
Okay, and then you divide by negative 1. Divide by negative 1, and you get x equals 32. Very good. So x is 32. Did it ask me for the angles or just to find x and y? So we're good here. How can we find y, though? Dylan?
Opposite angles, can you do y plus 87 equals 4y?
Excellent. Y plus 87 should be equal to 4y. Dylan, how would you solve this?
Subtract the y over, we get 87 equals 3y.
Mm-hmm.
And 3 divided by 87, and then you get, when you divide it, you get 29.
29 is correct. Very good. So if x is 32, y is 29, what kind of shape do we have then? A parallelogram, okay? That's what this question is asking us for. What values would make this a parallelogram? And you know that opposite angles must be congruent in parallelograms. So just make sure that when you plug in x and y, the opposite angles are congruent. Any questions on this one? Pretty straightforward, right? Okay. Now, in the last problem, it's not as difficult as it seems because you can literally use any of the 5 ways to prove that this is a parallelogram, okay? And that's all it's asking, is show that this quadrilateral is a parallelogram, okay? So What method would you guys like to use of the 5? Sophia? Yeah. Was that a hand?
No.
Oh, it wasn't a hand? Okay. Yeah, Carson?
Just use the definition of every side parallel.
You're so smart. It is the definition of a parallelogram. Why is that one the easiest, Carson?
Because you,
Juliet?
on the specific one, you can just count it.
Yeah, because you can just count it to find the slope, right? And once I find the slope, what am I doing with the slope? Am I using it for anything? Very good. You make sure that the slopes are equal across the opposite sides, right? And that's the definition of a parallelogram. Now, guys, don't get me wrong. If you are like in love with the distance formula and you just love using it so much, you can totally prove that AB is congruent to DC and BC is congruent to AD. But do you guys agree that finding slope is a little bit easier than using the distance formula? So my recommendation is just prove that opposite sides are parallel, okay? So do you guys agree we need to prove that AD should be parallel to what other side? BC. And then we also need to prove what? AB is parallel to what? DC, okay? So we would also need to prove that AB is going to be parallel to DC. All right, let's get started. So let's go ahead and find the slope of the first one, which is AD. Let's find the slope. The slope of this guy would be, we're going down how many? Is that 3? And then to the right, what? 3. So what is slope? Which one goes on top? Bless you. -3 over 3, which turns into -1. Always simplify it because sometimes they won't be equal until you simplify it, okay? The second one, well, let's do BC. Start at B. How do we get to C? Down 3 and then to the right 3, right? So my slope of BC is what? -3 over 3, which simplifies to? Have I proved that they're parallel? Bingo. Is it enough to just prove that one of the two sides are parallel? It's enough to prove that just one set of parallel sides is there? No, you've got to prove both. Even though it's obvious, okay, you have to prove both. So let's prove the second one. So let's go ahead and we'll do AB first. Let's find its slope. What's the slope of AB? I'll take a volunteer.
2.
Juliet?
2.
1 over 2? It's going up 2, right? Oh, no. It's going to the right 5, though. Not 6. Wait. Right? Is it 2 over 5? Okay, so the slope is 2 over 5. And the slope of DC should be the same, right? Up 2, and then to the right, yep, 5. So plus 5. So this one's also 2 over 5. Once we show that they're congruent, we're done. We just put a check mark, okay? Did I do it wrong? No? Okay. Any questions, guys? Ask me now. Yes, Dylan.
You have to do both sets to know that's.
You sure do. Or you could prove one set is parallel, right? And then use the distance formula and prove that they're congruent as well. But I personally would stay away from the distance formula unless it's like a purely horizontal or purely vertical line, okay? Because, I mean, finding the distance of this, you know that this is 3 units, right? That might be easy. But in terms of like, if you're given something like this, where distance formula is not going to be super trivial, I would definitely prove that they're both parallel. Yeah, Cody.
Could one set be parallel and the other one not be?
Ooh, could one set be parallel and the other one not be? It could happen. But what do we know about that figure then? It's not a parallelogram, okay? That would be considered a trapezoid, okay? And we'll get to that later. Any questions? I love these questions. Anything else, guys? Okay, so go ahead and turn these in, and then I have a little challenge for you, okay?